Hello people, welcome to Gurukula. I'm Jai. So today in this video we are going to see about the concept of frequency division multiple access. So if you haven't watched any of my previous video, I will leave the link for all the introductory videos of the subject related to wireless communication on the I button. So please do check the I button section for the links for my previous videos. So today, without any delay, we will get into the today's topic, that is frequency division multiple access, which is also abbreviated as FDMA. So before getting into the topic, that is FDMA, we should try to understand, or we will try to relate how multiplexing and multiple access are related. So generally, what do you mean by multiplexing? So multiplexing is nothing but it is a way of sending multiple signals or stream of information over a communication link. So when you look at the diagram, so multiplexing is a concept where the information generated by different users will be combined and it will be sent over a common communication link, and this process is what we call it as multiplexing. So now, what is multiple access? So multiple access is nothing but, so we know that there will be a base station, and then this base station will be shared between the different users. So now I should find out a technique so that the different users can able to access the channel between the base station and then the mobile station simultaneously and without any interference. So this technique is what we call it as multiple access technique. So the multiple access is a technique which is used to allow multiple users to access the channel that is available between base station and then the mobile station at the same time without any interference. So that is what we call it as multiple access. So multiple access can be performed in different ways, and we will be seeing it very soon. And then the basic relationship between the multiplexing and multiple access is, multiple access is actually an application of multiplexing. So this is a very basic relationship which has to be understood, that the multiple access is an application of multiplexing. So as I already said, multiple access can be performed in different types. So that is, multiple access technique is further classified into four major types, that is frequency division multiple access, time division multiple access, spectrum multiple access, and space division multiple access. Where spectrum multiple access is further classified into three types, that is frequency hopped multiple access, code division multiple access, hybrid spectrum technique. So today in this video we will be discussing in detail about the frequency division multiple access, and in the subsequent videos we will talk about the other multiple accesses in detail. So we will be discussing about the TDMA and then CDMA in the next subsequent videos. So today's topic will be frequency division multiple access. Hope you understood what multiplexing and multiple access are. So with this basic knowledge, we will get into the topic of frequency division multiple access. So when we talk about frequency division multiple access, now we know what multiple access is. Multiple access is nothing but it is enabling multiple users to access the channel between the base station and then the mobile station. So now the question is, the key question of the entire concept is, how do I differentiate the users? When I say multiple users, then there should be a principle which actually satisfies how do I differentiate multiple users. So the multiple users here in FDMA will be taken as the entire radio spectrum which is available over here. So let us consider that this is the entire radio spectrum that is available for the communication systems, will be further divided into several frequency ranges. So now this will be acting as a particular frequency range, this will be acting as a separate frequency range, and this is separate and this is separate. So when it is divided, and each and every frequency range will be allocated to different users like this. So as it is depicted in the figure, you could see that the different set of frequency is allocated for different users. So user 1 is using different set of frequency, user 2 uses different set of frequency, and user 3 uses different set of frequency. So it is clear that each and every user is differentiated in terms of frequencies. So that's the name frequency division multiple access, meaning each and every user will be differentiated in terms of frequencies. So user 1 will have different frequency, user 2 will have different frequency, and user 3 will have different frequencies. So that is what we will call it as frequency division multiple axis. So and now to check, each and every uses are separated by different frequencies, and you could also note that there is a gap intentionally left between each and every user, and those gaps is what we call it as the guard bands, and that is intentionally introduced to avoid the interference between user 1 and then user 2. So this is what we call it as the guard bands. So if the guard bands are not properly fixed, then or in other words, if the separation between user 1 and user 2 is not sufficiently spaced, then if this guard band is very less, then it will lead to interference, which means user 1 and user 2 will not be separated over a proper frequency ranges, so that it will give rise to the interferences between user 1 and then user 2. So this is a more formal way of representing frequency division multiple axis, and this helps us to understand the concept of how uses or how the channels are allocated to different uses in frequency division multiple axis. So this axis represents the frequency, and this axis represents the code, and this axis represents the time. So when we look into this particular diagram, you can observe that the frequency is divided into different channels, like channel 1 is of different frequency, channel 2 is of different frequency, channel 3 is of different frequencies. So each and every channel, so channel 1 will be allocated to a particular user, and channel 2 will be allocated to a particular user, and channel 3 will be allocated to a particular user, and so on. So that each and every user will have an unique frequency, so that they could able to communicate by using that particular channel, and all the communication will be done by using only with the frequency ranges allocated to that particular user. So this method of separation is what we technically call it as frequency division multiple axis. So just to take our discussion furthermore, there are certain things which have to understand on the frequency division multiple axis. So just to start off with, we will have a formal diagram, and we will try to understand what are all the other things that is in FDMA. So FDMA assigns an individual channel to individual uses. So each and every channel that we have separated here will be allocated to individual uses. So say for an example, user 1 will be using channel 1, user 2 will be using channel 2, user 3 will be using channel 3, and so on. So likewise, individual user will be allocated with an individual channel. And then each user is allocated an unique frequency band or a channel. So this is what we call it as a frequency band, a band of frequency, or we can call it as a channel. So this is allocated for each and every user, and it is important to notice that each and every channels will have unique frequencies, and none of the frequencies will be repeated again. So the channels are assigned on demand by the users. So the channel will be entirely available at the base station. Channel will be entirely available at the base stations, and when each and every user demands for a particular frequency, then the base station allocates a particular channel to the users. The same frequency is not allocated for two different users, which is just known by default. So the bandwidth of FDMA channel is relatively narrow, so that will approximately range only up to 30 kHz. So the maximum bandwidth allocated for a particular user will not exceed more than 30 kHz. So this actually makes the FDMA systems to an narrowband systems. So generally FDMA systems are implemented only in the narrowband systems. And then the amount of intersymbol interference is typically low. Since the interference is naturally low because of we are introducing the guard bands. So since we are introducing the guard bands, the interferences will go down naturally, so that there is no separate need for including the equalization techniques in the system. So that is an advantageous point of your FDMA. And moreover, it is also important to understand that FDMA is an continuous transmission, because we haven't made any separations on the time axis, so that whatever the channel that is allocated to a particular user, he can make use of this particular channel for the entire period of time. Since there is no separation on the time scale, see, this is the time axis and there is no separations made on the time axis. So any frequency that is allocated to a particular user, he can use it continuously as of his communication is required. So once the communication is done, the channel will be returned back to the base station. So this is what we call it as the continuous transmission. And then the overhead that is required for FDMA systems are also very less when compared to TDMA systems, and the overhead and then the TDMA will be discussed in detail in the subsequent videos, but as of now it is expected to understand that the overhead is very much lesser when compared to TDMA, which means the overhead of FDMA is less when compared to TDMA technique. And obviously FDMA definitely uses devices called duplexers, since both the transmitter and receiver operates at the same time. So since this is a full duplex concept, so we definitely need duplexers, so which will make the frequency separation between transmitter and then the receiver. So this actually, the use of this duplexers will actually increase the cost of FDMA, and this point will be considered on the disadvantages side. And FDMA requires tight RF filtering to minimize the adjacent channel interference, and it is understood that the guard band has to be proper between channel 1 and then the channel 2. If there is no proper separation or no proper guard band is allocated between channel 1 and channel 2, then definitely that will lead to interference between channel 1 and channel 2, and that interference is what we call it as adjacent channel interference. So the guard band has to be allocated very properly, which demands a tight RF filtering. So the RF filters has to be designed in a very stringent way, and it should work very accurately so as to eliminate the interferences between the adjacent channel. So these are all the various pros and cons of FDMA systems. So there is another important thing which has to be considered while discussing frequency division multiple access, which is nonlinear effects. So where does this nonlinear effects come from? So far we have discussed the concepts of FDMA from the mobile station perspective. So when you look at the base station perspective, in FDMA systems, so many channels actually share the same antenna at the base station. So say for an example, if a system of FDMA has 10 users, and all the 10 users will be using 10 different frequencies, we all know that, and from the base station it is not possible to install 10 different antennas to serve 10 different users. So usually on the optimal side we will be installing one single antenna as a base station which serves all 10 frequencies. So that is the meaning of this particular point, which means that many channels or otherwise many users will share the same antenna at the base station. So in order to serve multiple users, obviously the power amplifiers and then the power combiners which we use at the base stations will be operated either near saturation region or at the saturation region. So from the basics of power amplifier techniques, we all know that. So this is the saturation side and this is the load line. So when a particular power amplifier or the power combiners are operated to the point which is very nearer to saturation or at saturation itself, which will actually lead to the nonlinear effects. So the power combiners and then the power amplifiers will exhibit a nonlinear characteristics. So in nonlinear characteristics is generally nothing but that the signal will get spreaded, or it will introduce some intermodulation frequencies. Intermodulation frequencies, it will generate some other irrelevant frequencies or the frequencies which is not required for the signal processing. So this will be the case when the power amplifiers and the power combiners are operated either at the saturation region or near saturation region. So this actually creates a nonlinear effect, and because of this nonlinear effect the signal will get spreaded. So this spreaded signal will obviously cause interferences like this, and you could observe that the signal got spreaded over a particular region. So that is how the practical situations can be seen. And so this non-linearity effect will definitely introduce adjacent channel interferences. So this has to be taken care of. While designing the frequency division multiple axis, it is also important to take care of the operating ranges of power amplifiers and then the power combiners, so that it should not be kept saturation or near saturation, so as to suppress the adjacent channel interference. So next, to discuss about the capacity of FDMA. So what will be the total number of channels that I can create by using FDMA is given by, so number of channels that can be simultaneously supported in FDMA systems is actually represented by an equation. N is equals to Bt minus 2 times B God divided by Bc, and where Bt is the total spectrum allocation for the system and B God is the God band allocation at the edge of allocated spectrum. So B God is nothing but the God band frequencies, total amount of frequencies that is left for allocating the God bands, and BC is the total channel bandwidth. So substituting all these values will actually tell us what will be the maximum number of channels that can be created by using frequency division multiple axis technique. So that is all about the things to be discussed about FDMA. So just to summarize the concepts, whatever we have studied over here, we started off with the relationship between multiplexing and then the multiple axis, and then we understood that the multiple axis is an application of multiplexing. And later on we have understood that there are different types of multiple axis techniques available: FDMA, TDMA, spectrum techniques, and all these techniques are available, and out of which we have discussed in detail about the frequency division multiple axis. And in frequency division multiple axis, we just started off with the principle of operation, and then we discussed certain pros and cons related to FDMA, and then we have seen what exactly the nonlinear effects of FDMA, when does the nonlinear effects arises, and what will be the effects of, and what will be the causes of nonlinear effects of FDMA. So all these things were discussed under nonlinear effects of FDMA. And finally, what could be the total channel capacity of FDMA systems. So that is all about today's particular video. And I hope this video found useful to understand the concepts related to frequency division multiple axis technique. So we will see you soon in the next video. Until then, happy learning.